Okay, so in this video, I'm going to be looking at a few questions. Oops, let me get a new one here. Sorry. It's kind of slow to open. Okay, so in this video, I'm going to be looking at solving systems. But I'm going to do some that feel different than what you've had before, even though the method is exactly the same. All right, so the first example I'm going to do is this one. All right, what if I gave you a system that looked like this? All right. First off, we usually use X's and Y's, and I'm using W's and S's. Secondly, my numbers are bigger than you're used to. You're used to numbers like 5 and 7, not 4,414. All right, so we're going to work that one. Okay, another example I want to do is one that involves some decimals. Like, what if you had one where you knew X plus Y equaled 9,500, but then 0.12X plus, and I should put a 0 on that, plus 0.09Y equaled 1,032. Okay, so that problem looks a little weird because of the decimals. And then for the third problem, it doesn't look weird, but something strange happens when you go to solve it. Okay, so let's look at this one. So it looks like it's going to be nice and straightforward, but we'll see what happens as we solve this. Okay. So these are systems of equations. We're going to solve them. We already know how to solve systems, but these are just feel a little bit different than what we've been doing because like on number 1, the numbers are big. All right, so if I were approaching this one, I would think to myself, well, I've got the W over here by itself, so I'm going to use substitution on this. They don't tell you which way. I didn't tell you which way to solve it. My directions, by the way, would have just been solve. Okay, and then but because the W was by itself, substitution would be the best thing to do. Okay, so I've got these two equations. At the point of intersection, the W's are equal. So I can take that first equation, and where the W was, I'm going to put S minus 1,086. Then I still have the plus S. Let me do it in green. Then this is the rest of the equation that I haven't substituted in for. Okay, so I just took that first equation where that W was, that's where I put, this is where the W used to be, right? I won't write that. And I just put a W in there. All right, now these are on the same side of the equal sign. So I've got 1S and then another 1S. That's 2S minus 1,086 that equals 4,414. Okay, I need to get the S by itself, so I'm going to add 1,086 to both sides. Okay, then that leaves me with 2S equaling 5,500. Okay. I need to get the S by itself, so I got to get rid of the 2. And that's going to give me that S equals 27,500. Nope, I said that wrong. 2,750. Sorry, 2,750. All right, now we're solving a system, so we're supposed to get both pieces. So what I'm going to do is go back to that equation because that would be the easiest one since the W was by itself. And right there where the S is in that equation, so I'm taking this equation, let me just write it down first. And then right there where the S is, I'm going to put 2750. So W would equal 2750 minus 1,086. Okay, so that's going to equal, that's going to equal something. What is it? 600, 1,600 and something. Let's see. 2750 minus 1086. All right, so that's going to equal 1664. All right, and then these were unusual letters, so you might have wondered, well, what am I supposed to write first? Typically, when you don't know the context and you need to write it as an ordered pair, you typically put them in alphabetical order. So I'll just do that. So we had 2750 and 1664 for the W. Okay. All right, so this problem I was showing you because the process is the same as you do for any substitution question. It's just the numbers that you're working with are larger than you're used to, so it feels weird. Okay. So I'm kind of thinking by now you've got the basics of substitution elimination. So we're just looking at a few unusual problems. Okay. All right, let's work on that second one. All right, so on the second question, I have x plus y equals 9,500. And then I've got 0.12x plus 0.09y equals 1,032. So on this one, I've got these decimals on that second equation. I'm not used to dealing with that. But, in general, looking at it, the x's and the y's are on the same side. So I would probably use the addition or elimination method, whichever is making sense to you. This book calls it elimination, but other books call it addition. So looking at that, I might try to get rid of, say, the x. If I did, I would need what's in front of x to be the opposite of 0.12. So I'll just multiply here. Let me move this over a little bit. I'll just multiply by negative 0.12. Okay, let me do it in red because that's what I'm going to be putting in there. I'm going to multiply over here by negative 0.12. But if I do that on the left, I have to do that on the right. So don't let the decimals throw you. You can work to try to get keep the decimals and just try to get them to be opposites. Since there was just a 1 in front of the x up here understood, I could multiply by negative 0.12. This is positive 0.12. So those would wind up canceling out. So this is negative 0.12x plus, actually minus 0.12y equals 9,500 times negative 0.12 would be negative 1140. Then I'm just going to bring that second equation as it was written. 0.12x plus 0.09y equals 1032. All right, now we got them ready because now I can see that if I added these up, it'd be 0x, which is 0. Then a negative 0.12 and a positive 0.09 is going to be a negative 0.03y. Just do it on your calculator. And then a negative 1140, positive 1032, they'd be negative 108. Then you're going to divide by negative 0.03 on both sides. Then you get y equals, let me do that again. You got to be careful. The one thing on these decimals you got to be careful about is like this has an understood 0 in front of that, but when you type that in, when you divide by that, some reason it's not. When you divide by that negative 0.03 right there, don't drop that 0 between the decimal and the 3's. That's what I did when I typed it in. So that winds up being 3,600, 3,600. Okay. All right, so now, just like before, we got to pick an equation to plug into. It's just real clear that I would want to pick this equation. Let me take the x plus y equals 9,500. And then I'm going to replace that with the 3,600 and figure out what the x would need to be. So I'll subtract the 3,600 from 9,500. And that's going to tell me that x equals 5,900. Okay, and then your ordered pair would be 5,900, comma 3600. And you can check that you're right by putting in the 5900 for the x and putting in the 3600 over here for the y, and then seeing if 0.12 times 5900 plus 0.09 times 3600 really does equal 1032. That's the way to check it. So that one was weird because it had decimals in it. Now, when you look at view an example, they might have you do it a slightly different way, and maybe you'll like it better. I don't, because it causes me to get such really big numbers. So if I had this problem, here's your other choice. You could clear decimals. Okay, so to do that, you would look at how there's two places to the right of the decimal there and there. If I wanted to clear those out, I could multiply by 100. So if there's two decimal places, then you multiply by 100. And so if I multiply by 100, it'll move the decimal two places to the right, basically. So I could do that, but I have to do it over to the right-hand side also. So what that causes is me to get some really big numbers. So that's not going to be big, because 100 times 0.12 will be 12. 100 times 0.09 will be 9. But the right-hand side isn't just 1032. It's that with two more zeros. So you can do it if you don't like decimals in there, but you've got a calculator. And so really most people, when they're dealing with decimals, will just do that, multiply by negative 0.12, for instance. Okay. But you might see this in an example, and I want you to know that it's okay if you want to clear the decimals, or if you've seen that before. Okay. Then what you would do is you would come up here and you'd be able to multiply by just negative 12. Okay. So you'll get negative 12x minus 12y, but then you get this gigantic number, 9,500 times 12. You'll get a negative 114,000. Then you bring your other equation over. Then that's gone. You're ready to add. You get negative 3y. See, the decimal will be gone. Is why people sometimes do this. Then you divide by negative 3, and you get the same end result. And I'll stop there, but you could continue. You could go back up now and plug into here. All right, so if you ask me to make a recommendation, I would say keep the decimal in there. It's kind of like back with fractions. You could clear the fractions, but most of you decided not to. When we were doing equations with fractions, you just kept them in there because you had a calculator that would handle that for you. Okay. All right, so let's look at number 3. Here we have 2x minus 5y equals 4, and 7x minus 2y also equals 4. So I'm doing this third example. All right, so let me give myself some room. All right, now you might wonder why this one's on here, because it looks so straightforward. This one you should be pretty confident about. Okay. You could get rid of either the x or the y. I would think most of us would use the addition method. Okay. To get rid of the x's, you could multiply on top by 7, on the bottom by 2, but then both of those would be 14, so let me make it negative 2. And then I got to be sure I multiply the right side of each of those. Okay, so it feels like a really straightforward elimination question. Numbers aren't too big or anything. You just wait. I'll show you what happens. Okay, so you get to there. Be careful about your signs. The negative times the negative made that a positive. Okay, now you're ready to add the two equations. So this is gone. This becomes negative 31y, and over here you have positive 20. Okay, so at that point, you're probably thinking about something must be wrong, because you're getting y equals, and you got this fraction that doesn't simplify. You could write it this way or this way would be the two ways. Either the negative up on top or out in front is the two ways. Those are all equal to that. And you might think you did something wrong. And I still recommend if you get a fraction to double check everything, but that's why I'm doing this one. This is a system where the answer to the question has fractions in it, okay? So when that happens, those of you that are really good with your fraction keys can just take this and plug it in for the y. Take that equation right there if you want. And where the y is, put the negative 20 over 31. Okay, this is good this is okay to do, especially if you're comfortable with getting those fraction operations worked out. So a negative times a negative is a positive, and this would be 40 over 31. And then you could take away the 40 over 31 from both sides, and that would give you that 7x equals 4 minus 40 over 31. So 4 minus, that's where the calculator can come in handy. So just do 4. And I didn't need the calculator when I did the multiplying, but I do this a lot. So I know multiplying just multiplies 2 times 20 and 1 times 31. So that's why I didn't, but I could have used my calculator. So you could then take your calculator to do the last part, and we wind up having to change it. I had to change it back into a fraction and a mixed number, and I got 84 over 31. Then I needed to divide by 7. So I just kept that 84 over 31 and hit divide by 7, and it gives me the answer. Tells me x is 12 over 31. Turns out that's the answer. And I wanted to do a problem where it looked like it was real straightforward, nice, simple numbers. It's just that your answers turned out to be fractional. Okay, when that happens, there's a better approach than this right here. Okay, you know, we didn't get any fraction when we started. There were no fractions showing up until right there, okay? So a good approach on this, one of my students does this all the time anyway, is to go back now, when that happens, is to go back to the original problem that you had. And instead of plugging in this messy number right here, this 12 over 31, negative 20 over 31, instead of plugging that in and going through all those fraction things, what we could do is just go back to the original problem, start over again, and eliminate the y. Turn the numbers in front of y into a 10. So this one's negative 10 right now, so I need this one to be positive 10, so I'll need a negative on that. Okay, make sure you multiply both sides. So if I were working this problem, when I get a fraction for one of my answers, I just go back to the original system, and I kind of start over again, eliminating the other variable. So I just wanted you to be aware of that. Sometimes we're scared to do things that go, that are not straightforward, like an example, but this would really work well. So you then would get a negative 31x equals negative 12, and now is the first time we're getting fractions. You get x equals negative over negative would be positive 12 over 31. So that's better. This is better than doing the usual, which is to take that negative 20 over 31 and plug it in and work it out. But that way we just did it, more people would have gotten that one correct because there's no fractions until at the very end. So that's why I was showing you that one. So I asked you to really work hard on substitution elimination so that all you have left, so that now we've done all the basics. So all you have left is to build a little more confidence and not get thrown when you get these slightly unusual problems, okay?